All right. Hands up who uses Google Cloud? Yeah, okay. Quite a few people. It's good. Has anyone heard of DevOps in the context of it not being a job title? A couple of people. Okay. Okay. It turns out DevOps is not necessarily a job, even though a lot of people think it is. It's more like a platform engineer. But DevOps is a organizational and cultural movement that aims to increase software delivery velocity, improve service reliability, and build shared ownership among stakeholders. Now, this is from a Google Cloud presentation. I can't remember which one it was. I took a screenshot and then pinned it to my Twitter feed. So like I know the date, but I don't know which presentation it was from, so I'm sorry about that. But yeah, that's the general overview. The highlights are my own. So yeah, overall, the aim for DevOps, good DevOps practices, is to deliver at speed, improve reliability, and share the ownership of software. So what are we going to talk about today? We've got a couple of things just going to sort of take you on a journey. We'll start with our code safeguards, what we can do to protect ourselves. What happens after we merge to the main branch or the master branch? Look, we're in production and now the house is on fire, but I don't know why and I don't know where the hose is. Okay, we found the problem, let's fix it. And then we're back to green, and then we'll cover things like a post-mortem. And then got some time at the end for some questions and links. I thought it might be fun, since this is a developer focused, to put a README in my presentation. But I don't know if anyone's ever had a README in a slide deck before, but I thought I'd give this a shot. So how to use this presentation? Basically, we'll have the topic sections that we just talked about at the top of each slide so we don't lose ourselves. I used AI-generated images to look cool because apparently AI is a new thing now. And yeah, searching for images that aren't like copyrighted or protected, it's too hard, but Google have a cool little tool on the side of the slide deck where you can just type in like an image and it will just generate you one, which is great. And we've got the Google Cloud icons representing each of the services that we're going to be talking about that can help us achieve that good DevOps practice. Memes where necessary. I just realized I forgot to include one, but we'll get to that. And then, yeah, afterwards, I've got a link to the slide deck if that's something that you want. So let's get started with code safeguards. What can we do to protect ourselves? Again, AI images. So there is a weird one in there, so keep an eye out for it. Let's make sure that we build and develop our code the same way. Has anyone heard of the Three Musketeers? Yeah, okay, cool, a couple of people. Yeah, so the Three Musketeers is basically a practice where we use Docker and Docker Compose to build and develop and deploy our code and test it in the same way. Because everyone's machine is different. I have a Mac, you might have a Windows machine, or in my team at least, I've got someone who has a Linux box, someone's got Windows 10, someone's got Windows 11, and various versions of Mac OS. Maintaining all of those different dependencies becomes very, very problematic, especially across different stacks and even CPU architectures, so ARM and x86, 64. So Three Musketeers aims to try and solve that problem by creating a reproducible build, test, and develop and deployment environment. We can do other things to protect ourselves, like automated reviews from systems. So you might have seen things like ReviewDog or code coverage, those sorts of things, which sort of leave commits or comments in your code in a pull request. And obviously peer reviews as well, even better. AI isn't just not there yet. I don't think it ever will be, but we'll see. And yeah, protecting us from ourselves. We've got automated test runs in a pull request. Linting, people will argue to the end of days about tabs versus spaces, but this is really just to protect ourselves from enormous diffs where there's nothing changing except for tabs. And then building. So can we build the code that we're proposing to merge? So a couple of tools there, Cloud Build. If you've not used it, it is similar to GitHub Actions, if you've used that, or the GitLab equivalent, I can't remember what they call it. But basically, it's an ephemeral compute. It runs Docker images of whatever you want to do. So you can have any version of any language that you want, and it will build, test, and compile your application. And the Three Musketeers that's its little logo there. I don't actually know. There's an octopus and a whale, like the Docker and something else, but I don't know what the guy wearing the hat is. But anyway, as an example, this is a Cloud Build YAML file, which explains to Cloud Build how to build and test the code. So in this case, our backend, we're building a backend file, a directory, and it's in Go. And so we provide an ID to identify what step we're doing, provide a directory to build in, give it a name, so the name of the image that you'd like to use, and the entry point. If you're familiar with Docker, this is probably looking pretty similar to you. And then any arguments that you want to provide to that Docker image when you want to run your test. So in this case, it would be go test, pass in a cover argument, and we want to run tests across the entire folder and any of its subfolders. And then similarly for building, same sort of process. We use, in this case, we're using a make file. So we just say make build and then pass in a tag that we'd like to build. This is a copy paste from one of my side projects, so ignore the bit that says scorecard backend. And then at the bottom, we've got things like substitutions that we want to do. So we could do here things like API keys or secrets if you want to bake them in. Not that I would recommend that. Other things like image names. So in this case, short SHA is the commit hash that's provided by GitHub as part of the commit. Sorry, Git as part of the commit. And you can tag your images with that commit so you know which version of the software it is that's been pushed up to artifact registry. Cool. So you've merged to main. We got all our status checks passing. We got a tick from someone that says, looks good to me. I'm not sure if they actually read it or not, but you know, we got the tick, and so we've merged. Now what happens? Well, this is also a generated image, and that's meant to be merged. I typed merged code, and I used the cyberpunk theme. So like, yeah. So we got build, test, deploy, repeat. That's really the mantra here. And we can use Cloud Build to build our code and create an artifact off the main merge. But importantly, we don't want any humans involved in this process from now on. Once our code is merged, we want computers to take over. This will make our security team very happy because they don't like people click-opsing things. So ideally, infrastructure as code, all that sort of goodness. That sort of consistency that we get by not having people click off stuff means that we can reproduce in build environments. We can tear them down and rebuild them if we need to. And some of the services that you might want to consider in this step of the process would be Cloud Build. Cloud Build will create an artifact for you. So again, going back to the previous example with our Go backend, it will create a Docker image and it will push it to artifact registry, which is the bottom service there. Which can hold all kinds of artifacts. So Docker images, node modules, Maven files and directories, all that sort of stuff it can hold. And Cloud Deploy, which is a relatively new service, came out 18 months ago, something like that. It's a tool that can manage the deployment of our services for us to different environments. We can have things like stage gates, if you want to have QA approval, that sort of thing. And also it can do canaries with testing certain amounts of traffic through different environments to make sure that everything's going green. But the important thing here is that we build our software and then we deploy it to maybe a staging environment, and we'll run things like integration tests to make sure that the features that we're building work in the cloud and they work as our users would expect them to work. Basically what we're looking for here is that our tests are passing. We've got our code passing any vulnerability checks if that's been set up. And maybe the product team or the QA team have given the green light. And now it's time to deploy to production. Look, I'm in production. So again, this is AI. I typed production rocket, and that's what I got. And so, yeah, some of the stuff that you might want to look at in production. So things like monitoring, logging, observability, tracing, metrics, all that sort of goodness will be how you can tell if your system is working the way you're expecting it to. There's a wealth of services that you can use, either first party with GCP or third party, like Datadog, Grafana or something like that. And you can do things like understand how your service is performing. Is the CPU spiking through the roof? Have you got 800 pods running in production that you weren't expecting? You know, what's the memory sort of consumption looking like? The throughput of your service, any kind of traces and metrics that you're interested in. And the services that you could use for this, and I'll show you some examples in a bit. Cloud Trace. So anyone does distributed tracing or tracing across microservices? Yeah, a few people. Yep. So the premise with tracing is that if I am a user, for those of you who don't know, tracing is I make a request, and then like a request ID might be generated, and then it goes through various systems. So I might hit a front end, and then that front end is going to respond to some downstream service, which then goes and queries a database and comes back, does a round trip back to the user. So the idea is that you can understand how long it takes to go between each service and where there might be bottlenecks. And that sort of tracing really gives you an insight into how your code is performing in production. Other things you might be interested in are the metrics, so both system and custom. System metrics being things like CPU utilization across your pods or VMs, memory consumption, that sort of stuff. And then you might have something a bit more custom, like say, for example, you've released a new feature and you've made a product announcement. You might want to track how many users are signing up per hour or per minute or whatever the case may be. And you can do that with different custom metrics. Cloud logging is a good one for that. You can do specialized log queries and create a custom metric from that and then generate a chart. And then also cloud monitoring for your system metrics as well. Hang on. Ooh, I think I've broken the order of my slides. No, I haven't. I just forgot to do the next introduction. The next one is, oh no, the house is on fire, but I have no idea why, where the hose is. It looks like our rocket's exploded. There's errors everywhere. That was meant to be my meme that I forgot to put in. Please excuse me, I was up till 3 o'clock this morning because Perth time is midnight and it's 3 a.m. here. I couldn't get to sleep and I was doing my slides at the last minute because, yeah. Anyway, so yeah, errors everywhere. That's just imagine Buzz Lightyear, errors everywhere. But we want to know, why is the thing blowing up? The charts we have don't help. Our Kubernetes cluster is scaled up to 1,000 pods or 800 pods. We don't know why. But this all comes down to, why is the expected business value not being delivered? So we made this thing, we shipped it out, and our users can't use it, even though we may have sold this. That's the crux of the problem, but we got to figure out what has changed in our application code that is not working the way it used to. So something that's like awesome for this is error reporting. Does anyone use error reporting on GCP? One person, okay. They don't really talk about it that much, so maybe that's the reason, but it's an amazing service. And it will, if you ever log into your GCP project and you go to the dashboard page, it will actually sort of surface up to you saying, oh, we haven't seen this error before. This is a new error. It's like the first time seen was on this time, and it gives you the call stack, trace down to the line of code that's happening. So it's very, very useful. And there's a link at the end of the presentation that I can share that at Cloud Next this year, so like this time last month, I think, they had a presentation during the keynote where an error had been generated from the application somehow, and then the developers were sent an alert saying, oh, there's errors. And using the Duet AI thing that they've got in the GCP console, they clicked through the error, they got the exact line of code where the problem was, and they could use the AI, Duet AI to go, oh, this is the problem, this may be a solution, and this is how you can fix it, and this will do these things. And to go from like an email error alert to a potential solution in like less than 2 minutes is incredible in terms of progression from how far this has come. If anyone's ever had to debug errors in production and like fix something that's on fire, this is insane. From something that would take sometimes days to figure out and then fix and then deploy, to get this information in 2 minutes is amazing. So what can we do about this house on fire? How can we find the hose? And will water come out when we want to use it? So the best thing to do in this instance would be to find out what your users are reporting as an error and work backwards. So start with the user and then go, okay, this is the problem that they're having. Then what you can also do is generate test cases for that. I'll get into that in a minute. But for example, the user might be complaining, saying, hey, I can sign in, but when I view this page, I'm not shown any data. So that would be a starting point for where you might want to work backwards from. This was I don't know why there's like a clown face there, but it's a bit weird. I just said like man fixing rocket ship into the thing, and that's what I got. So yeah. So yeah, start with the error that your users reported, and build some unit tests and integration tests from this error. This is a really good way to prove that the error exists and that it's reproducible, and that you know that when you address the problem in code, that your tests go green, that you know you've solved it. Otherwise, you could be at this for hours, days even, and not even be sure about if you fixed it or not. And so then, this might look familiar, but build your unit tests, integration tests, peer and automated reviews, status checks, testing, linting, and then we're back to cloud build and the Three Musketeers again. So we're getting into this cycle of build, test, deploy, repeat. And this is really, really important in order to move fast, because you don't want to move fast and make it worse. You want to move fast and make it better. So by having really good testing in terms of both unit and integration, and even end-to-end tests, which can be very slow, but definitely worthwhile, you can really be sure that the software that you're shipping out is really robust. So talked about cloud tracing before, but here's an example. This is a monitoring and observability sort of thing that Google Cloud offer out of the box. So you need to instrument your code. These metrics will be given to you for free. These are, by the way, copy pasted from the docs, so they're not real. But anyway, so is the thing doing what we expect? We've proved it in unit tests and integration tests, but does the production data prove it? Can we tell that all of our users are getting the service that we're expecting them to get? And we can do this with tracing. So you might see from the example there that someone has created an order and you can see as the service goes through, it starts with payment processing, and then it hits a backup service, and it hits CMS, web hosting. You can sort of see the trace as it goes through the different microservices, and you can also see the names of the traces. So you've got get users by name, delete product, create payment, that sort of thing. So you can see how long it takes for the request's lifecycle to get through your different microservices. And that's so that's a sort of quick overview about tracing. And then on the other side here, we've got the observability for your containers, or this is a Kubernetes cluster, so it has the observability for containers. And you can see things like how often your containers are restarting every minute, if they are. You can see things like memory and CPU consumption, and sort of gauge like what looks normal versus what's out of the ordinary. All right, green, green, green. The grass is back. The tests are proving that the bug that was fixed and that our error reports have dropped off. Again, error reporting can actually tell you this as well. So it'll say last seen at this time, or first seen. So if you haven't seen it for a few days or weeks, then you've got pretty good confidence that that bug was fixed. And that also our service is scaled back to regular levels. It's not running 800 pods at midnight. And most importantly, our users can do the thing. Our stakeholders are happy because we've delivered that business value. So really, one of the key tenets I'm trying to get across here is that one of the things you might be interested in keeping track of is your mean time to recovery. And the mean time to recovery is one of the DORA metrics, which anyone knows about DORA yet? Okay, cool. Yeah, so mean time to recovery is how long it takes for your system to recover from an error. And if you have really good practices built into your engineering habits, where you test all your code and you release frequently, then you can reduce your mean time to recovery quite significantly. All right, so everything's good. Now what? That funny voice a few minutes later, and then that we've got we should do the postmortem. And postmortem is probably the most important thing to do in this entire process. Once you've solved the customer issue, of course. And it's about how you can improve not only yourself, but the team and the organization as a whole. And it identifies things like where your team really did well and what they were able to solve quickly, and also identify any weaknesses so that you can try and make them better going forward. And anyone heard of the 5 whys? One person keeps putting up their hand. Yeah, the 5 whys is a principle that says you keep asking the same question you keep asking, why did this happen 5 times? So you say, okay, well, my car's battery is flat, is the example in the Wikipedia document here. Well, why is the car battery flat? Well, because we didn't do the maintenance of the alternator. Why didn't we do the maintenance of the alternator? Oh, because we didn't get it into the service thing in time. Why didn't we do the scheduled service? Oh, because something was busy. So you get eventually down to the root cause of why something is broken. Usually it takes up to 5. Sometimes it's 6. Sometimes it's 4. Sometimes it's less. But asking these questions can really help identify what the root causes of an issue. But lastly, I really want to iterate on this one. This is super, super important. Postmortems are like a meeting where people talk freely and should be able to do so in a safe space. So don't bring an ego or a flamethrower to these meetings. In fact, you should never bring an ego or flamethrower anyway. But the reason for that is that by keeping a postmortem blameless, people are able to talk freely about the events that happened. And that sort of discussion is really, really healthy for getting really good outcomes and good discussion going about how you can make things better. If people feel safe, they can talk about stuff without being raked over the coals for accidentally writing a line of code that caused production to go offline. And that psychological safety that you get out of that is really good for building healthy teams. All right, this is a bonus slide, which I really wanted to include. This is in one of the talks that I talked about, that I mentioned earlier, that was given at Google Cloud Next. This is DevOps according to Google Cloud. This is all the tools that they offer. I've talked about some of them. So on the left, you got Cloud Code and source repositories. So if you've got Visual Studio Code or your editor, that's the same thing. And GitHub. Cloud Build, which we talked about at length, to build, test, and deploy your code. Cloud Deploy, if you want a managed way of doing that. Like, for example, you want stage gates or you want to release canaries and do those sorts of testing before you release to production. Artifact Registry for both holding your Docker images and doing security scanning and that sort of stuff. And then there's some tools that you can use at runtime. So Geshan did a great talk before about Cloud Run and Cloud Functions. I briefly mentioned Kubernetes. There's some other services as well. Unless you're in big enterprise, you might be using Anthos. But if you're not, Firebase and Compute Engine you've probably come across. And then, yeah, the operations stuff is all the logging and monitoring. There's also tracing and error reporting mentioned as well. Okay, I got some links. So can't click on them now, obviously, but this is also AI. I liked this one. I thought it was cool. I'm also a big fan of Star Wars, and it kind of reminded me of it. Yeah, the keynote link at Next with Priyanka talking AI DevOps is incredible. I highly recommend it. Then I've got that actual, if you take the slide, that's linked to the exact moment in the hour and 50-minute talk that it is. So it's like a 2-minute section, so it's well worth to watch. Three Musketeers. The 4 keys as well is also really, really interesting. That's also developed by Google, and it integrates with all of the GCP services, so you can check how your progression is against those DORA metrics. This came out like a couple of days ago, I think, but the critique of the McKinsey Developer Productivity Review is an amazing read. Like, amazing read. A guy pulled it apart and dissected it and just talked about team health and operations and how you can do things better. And then, yeah, a couple of talks on modern CI/CD, serverless, and then, and then the bottom one, this is a self-plug, I guess. Last year, I spoke at Next, and the serverless automated continuous delivery pipelines with Cloud Workflows, which is like a serverless tool that you can use to orchestrate lots of different stages of a long-lived pipeline and there's some open source code to go with it. All right, that's DevOps on GCP in less than half an hour. Any questions?
Hey, thanks for the talk. That was really great. I just wanted to check if you come across any tools in GCP stack for doing controlled rollouts. Like you don't want to deploy all at once, but maybe 10% of your users.
Yep. Yeah, for sure. Like with many architecture questions, it depends. Cloud Run provides this out of the box. So you can say, I want to deploy a new version and only serve 10% of the traffic, for example. Otherwise, if you've got something like Kubernetes cluster, for example, there is a Istio, which is like a service mesh that you can use to control that. Istio is a managed service with Anthos. So it's like managed Istio, I guess. So GCP do offer that if you're running Anthos. Yeah, for Cloud Run, for sure, you can control the traffic that's going to your services. So you can control that rollout if you want to do 50-50, or I think it's like 1% you can do, or any percentage. That answer your question?
Yes.
Yeah.
Great presentation. You know how a lot of clouds now create similar solutions, like for example, AWS, instead of cloud build, you have code build.
Yeah.
Any benefit GCP has that other clouds don't?
The reason I like GCP's version is that everything is a Docker image or a container image. And so if you want to run a specific builder of something, you can. So you might have like a Terraform, for example, and you just want to run a plan. You can build a Terraform Docker image and store it in artifact registry or wherever. And then when you want to do your CI or your testing, you just pull in that image and it will run on that image. So you can create these CI machines that are used across your entire organization, which has specific dependencies, some of which may be private, to your organization, and package that in a container, and then also version it. So that's one of the reasons I like, I'm gonna get this right, hang on, cloud build over code build. Also, I prefer the syntax between the two. Yeah, so that would be.
Great presentation. Circling back to the question that was asked earlier, that we can do 10% releases or 2% releases. Does Google provide out-of-the-box solutions to monitor specific 10%, or is it just clubbed in with all the general deployment?
So yeah, out of the box, GCP has the percentage of splits. If you want something a bit more controlled, like versioned APIs or something like that, then you probably need to manage that yourself, I would say. I don't know of anything specific off the top of my head that allows you to do different types of granularity in terms of sending traffic to different containers, yeah, other than the percentages, yeah.
Cool, thank you.